Good morning, all of you. Now I will present one screen to you. Is it okay or not? You let me know. Can you see the board? Can you see this board? Can you read the font? No, no. Is it okay? Not clear. Then we go to previous one only. Yes, let's see this question number 10 now. Today, let's see question number 10. Can you see the board clearly now today? This one, question number 10. Once read question number 10. In question number 10, it was given. Good morning, good morning. Can you see the board now? Is it clear? Question number 10. Read question number 10. One bulb is of resistance 1100 ohms, draw from a 220 volt, and another one. How much current will an electric bulb of a resistance 1100 ohm draw from a 220 volt source? If a heater of resistance 100 ohms is connected to the same source instead of the bulb, calculate the current drawn by the heater. So here we have to find out how much current is drawn in both the cases. Is it clear my voice? In the first case, current formula is what? We know voltage and resistance here. Now we are talking about question number 10. Current is equal to V by R. So in the first case, V is equal to 220 volt and R is equal to 1100 ohms. And what is I? I is equal to 220 by 1100. R is equal to 220 by 1100 in the first case. So what happens here? 0, 0 cancel. 11 tens are 11 twos are. So it is what 2 by 10, which is 0.2 amperes in the first case. Current drawn in the first case, it is 0.2 amperes. Whereas current drawn in the second case, what happens? In the second case, V is equal to same 220 volts. It is not changed. But resistance is of only 100 ohms. In this case, it will be I is equal to 220 by 100. 220 by 100. 220 by 100 is how much? 0, 0 cancel. It is 2.2 amperes. So current drawn by the heater will be more than current drawn by the bulb. An electric bulb of resistance 1100 ohms draw from a 220 volts. If a heater of resistance 100 ohms is connected to the same wire, same source, instead of the bulb, calculate the current drawn by the heater. The current drawn by the heater is 2.2 amperes. Current drawn by the bulb is 0.2 amperes. Is it clear? Shall we go to the next one now? Question number 10 is done. Now question number 11. Read question number 11. Two bulbs A and B rated 90 watt, 120 volt and 60 watt, 120 volt respectively. They are connected in parallel across 120 volt source. Find the current in each bulb. Which bulb will consume more energy? We should find out current and energy also. So how do we find current again? Like same formula, but here power and voltage is given. When power and voltage is given, which formula we have to use? Power is equal to voltage into current. Power is equal to voltage into current. V into I. So in first case, what is V? V is given 120 volt. In the first case, 120 volt and power is given 90 watt. So we want I, find the current in each bulb. So I in the first case, I is equal to P by V, because P is equal to V into I is equal to P by V. So what is P now? P is 90. What is V? 120. So what happens here? It is 3 table, 3 ones are 3 fours are 3 by 4 amperes, or you can also write 0.75 amperes. This is what I in the first case, current in the first case. Power is equal to I is equal to P by V, because power is equal to V into I, then I is equal to P by V, 0.75 amperes in the first case. In the second case, we have to find same way. So in the second case also, V is same 120 volt, but power is only 60 watt. In this case, what happens? I is equal to same formula P by V. So that is 60 by 120, exactly 2 times 1 by 2, which is 0.5 amperes. This is current in the second case. What they are asking to find the current in the bulb, in each bulb, which bulb will consume more energy. Now after you are getting, let us take this is I1, this is I2. After we are getting I1 and I2, we have to find out which will take more energy. Energy formula is what? P into I into T, but here time is constant. We will take time in both the cases same. Then what happens? Energy in the first case is where I is more, there it will be energy more. So in because I1 is greater than, you can write like this also. Since I1 is greater than I2, energy in first case will be greater than energy in first case will be greater than energy in second case. E1 is greater than E2. So bulb with first bulb will consume more energy. Hope you understood this one also. Now coming to question number 12. Now once read question number 12. Previously what we did? Current, power, voltage. When you want current, current is equal to power by voltage. Current is equal to power by voltage. So we got current in first case, current in second case. In which case current is more, their energy also it will be more. Okay, so current energy is directly proportional to current, square of the current. That's okay. Now question number 12. In question number 12, they said an iron consume energy at the rate of 840 watt. It's consuming the energy at the rate of 840 watt when heating is minimum rate, and 360 watt when heating is at the minimum. In the first case it is maximum, in the second case it is minimum. The voltage is 220 volt. What are the current and resistance in each cases? So we have to find out in the first case what is the current, in second case what is the current. So here also what it is given again, power is given in the first case P1, let us take it as P1. P1 is equal to 840 watt it is given. P1 is equal to 840 watt, and P2 V1, let us take one more watt it is given, 840 watt, but the voltage in both the cases it is same, 220 volt. 840 watt, 220 volt. What are the current and resistance in each cases? So when you want current, again like same formula, I1 is equal to power by voltage, P1 by V1. So power is 840 by voltage is 220. 840 by 220. So what it is going to be, 0 0 cancel. We cancel by 11 table, 2 table, 2 11s are 2 21s are. So it is going to be 21 by 11. 220 or 21, so 1 second. So it is going to be 242, so it is going to be 42 by 11, 242 by 11 amperes. So let it be I1. Now coming to I2, current in the second case, power is 360 watt by voltage is 220 volt only. 0 0 cancel. Again, if you cancel by 2 table, 2 11s are 2 18s are. So it is what 18 by 11 amperes. So this is what current in both the cases. Current in the first case 42 by 11 amperes. Second case 18 by 11 amperes. Now they are asking to find, in both the cases they are also asking to find resistance. You can leave like this 42 by 11, 18 by 11, or if you want to convert them into decimals also, you can convert them into decimals. Right now, after we are getting this, they are asking to find resistance. Resistance, how can we find resistance? R is equal to V by I. R is equal to V by I because V is equal to I into R. So V is what 220 same, but I is what 42 by 11. So we can write it as 220 into 11 by 42 because 42 by 11 will become 11 by 42. So if we cancel these two again by 2 table, 2 21s, 2 110s. So it is 11 into 110 by 21. So it is 1210 by 21 ohms. Still you can, if you want to convert that into ohms, decimals, you can convert or you can leave like that. Even second case also both the way, same way. R2 is equal to 220 by, in the second case what it is 18 by 11. So it will become 220 into 11 by 18. After cancellation 2 nines are 2 110s are. So it again it is 110 into 11 by 9. So we can also write it as 1210 by 9 ohms R2. So what we did here, first we did what is I by using the formula, of P by I, no, P by V, because P is equal to V into I, and then later we used the formula to find out resistance, we used the formula V by I, V by I. That's okay. Now let's see this question. Two lamps, one rated 100 watt, 220 volt, and another rated 60 watt, 220 volt are consuming connected in parallel. So we have to find out the current. I think this was the same repeated question like what we have done before. Now let's go for this question number 14, which is series and parallel connection. In question number 14, what happened, once you see, if you observe in question number 14, those circuits, they are asking to find ammeter, voltmeter readings in both the cases. Voltmeter readings in both the cases. Observe the pictures carefully. So we have to find out voltage across this total 3 ohms and 3 ohms. We have to find out voltmeter readings in both the cases. So in the first case, if you observe, the two resistors are connected in series. One is of 2 ohms and other is of 3 ohms. Correct? So here we have ammeter. Here battery. like this we have circuit, and here we have voltmeter. Voltmeter is across combination of 2 ohms and 3 ohms. So what we must do, we find out the total resistance, we get 5 ohms, and we get some voltage. So here voltage is given 3 volts. Voltage is given 3 volts. So what happens here in the first case at 2 ohms, V will be divided as V1 plus V2 because they are connected in series. V will be divided as V1 plus V2 because they are connected in series connection. When they are in series connection, so what is V1? V1 is equal to 2 by I will be same. So IR. So I into 2 ohms plus I into 3 ohms. So that is going to be 2I plus 3I. So 5I. V is equal to 5 into I. So because we do not know I, we will keep like this 5 into I, which is nothing but 3 ohms. It is given 3 volts already. So overall voltage will be 3 volts only because voltmeter reading will be 3 volts only because it is connected across series combination of these two, 2 ohms and 3 ohms series connection. So final result is going to be 3 volts only, even though current we do not know. If you want to find current also we can find. One is I1 is equal to what? V by R. So 3 by 2 plus 2 by 2. What is current formula? Current is equal to V by R. So 3 by 2 plus 2 by 2, which is 5 by 2. We want voltage. What is V1 formula? V1 is equal to I1 R1. We do not know I. Let it be like this, but overall 5I it is. 5I is nothing but again 3 volts only. In the first case, even in the second case, 3 volts are there, but voltage in the parallel connection, if you see, voltage is not divided in the parallel connection. Here 3 volts it will be, here also 3 volts. In both the cases it is 3 volts. Here why it is 3 volts? Because we are taking overall together. That's why overall it will be 3 volts only. V1 plus V2 is again 3 volts only. Here because voltage is not divided, again it will be 3 volts only. So in both the cases, voltmeter reading is going to be 3 volts as it is. 3 volts only. Now let us see this question. Observe this figure. We have to find out current in 3 ohms resistance. We have to find out current in the 3 ohms resistance. Question number 15. How do we find current in the 3 ohms resistance? They are in, first we have to find out total resistance. How can we find total resistance? First 3 ohms and R1. Let us take R1 is equal to 10 ohms. R2 is equal to 3 ohms and R3 is equal to 6 ohms. Now R2 and R3 are in parallel. R2 and R3 are in parallel. When R2 and R3 are in parallel, their effective resistance is 1 by R is equal to 1 by 3 plus 1 by 6, which is 2 plus 1 by 6, which is 3 by 6. After cancellation, 1 by 2. 1 by R is equal to 1 by 2. When it is 1 by R is equal to 1 by 2, therefore R is equal to 2 ohms. Now this 2 ohms and 10 ohms, 2 ohms and 10 ohms are in series. 2 ohms and 10 ohms are in series. So what we do, now total resistance we will find out. Total resistance is 12 ohms. Total resistance is 12 ohms. Now we find out current. Current through 10 ohms and 12 ohms. Current through 10 ohms and 2 ohms is same because they are in series. This is 10 ohms and this is total together it is 2 ohms. So current through 10 ohms it is current through 10 ohms. How can we find? Current is equal to V by R. V is 12. 12 by 10, which is 1.2 ampere. This is current through 10 ohms. Then current through 2 ohms also. Current through 2 ohms also 1.2. But this 1.2 amperes will be divided now. 1.2 when it comes to 3 ohms and 6 ohms it will be divided. Now current through 3 ohms, one second, we will do here again. Let's see this, what happens. So overall resistance we got. Overall resistance R is equal to 12 ohms and overall voltage V is equal to 12 volts. And overall current I is equal to V by R, that is 12 volts by 12 ohms, which is 1 ampere. Overall current is 1 ampere. Overall current is 1 ampere. Means through 10 ohms and 2 ohms it is traveling 1 ampere only. 1 ampere current is going. Now current through 3 amperes, what happens? This 1 ampere will be divided. I1 if you take it as I1 is equal to we will find out V value how it is divided first. V1 is equal to I into R1. So that is 1 into 10, 10 volt. V1 is equal to 10 volt. V2 is equal to remaining 2 volts it will be. Now I1 is equal to I is equal to V by R. So V is 2, 2 by R is 3. So 2 by 3 amperes. This is current through 3 ohms. If you want current through 6 ohms, it is 12 by 6. 2 by 6, it is 1 by 3. Now let's see this question. This is also one different question in this. Like this, if these are connected, how do we find resistance through resistance from A to B? How are they connected? Resistance from A to B, how are they connected? How these resistors are connected? R1, R2, R3 are in series. If you see here, R1, R2, R3 are in series. So what happens? R is equal to R1 plus R2 plus R3. So here what happens? All of them are 1 ohm only. So 1 plus 1 is equal to 3 ohms. This is first path from here to here. From here to here, total resistance 3 ohms. Similarly, from here to here also, total resistance 3 ohms. So again, in the second case also, let us take this as R1, 2, 3. Now R4, 5, 6 is also 3 ohms. In total, these two are connected in parallel again. These two, upper part and second part, they are connected in parallel. So what happens here? These two, when they are connected in parallel, total effective resistance will be 1 by 3 plus 1 by 3, 1 by R. 1 by R is equal to 1 by 3 plus 1 by 3. So 1 by R is equal to 2 by 3. Then R is equal to 3 by 2 ohms. That is equal to 1.5 ohms. 1.5 ohms. First path is connected in series. First path is connected in series. So 1 plus 1 plus 1, 3. Again down also it is 3. They both are in series, 3, 3. Now the results are connected in parallel. Because they are connected in parallel, 1 by R is equal to 1 by 3 plus 1 by 3, 2 by 3. So 1 by R is equal to 2 by 3. So R is equal to 3 by 2, 1.5 amperes. Okay, that's okay. Now here I see many people confused about this also. Question number 19. How they are connected? Question number 19. In the first case, if you see point resistors are there like this, one is like this. This is A to P. A to P is there like this. Again P to Q. If you observe P to Q down, this is P to Q. Again Q to R. Q to B it is. Like this we have all are in parallel. See, how do we decide they are in parallel or series? It is there like this, right? When it is there like this, suppose current starts from here. When current starts from here, after it is coming here, it will be divided up and down. But up nothing is there, no? Nothing is there to travel. So the entire current goes from here only. So what happens here? We consider all these three in series only. In the first case, we consider all the three are connected in series. So that's why we add all of them. Then R will be equal to 5 plus 5 plus 5. So it is going to be 15 ohms in the case 1. In case 2, in case 1 it is 15 ohms. But in case 2, we can redraw this figure like first resistance 5 ohms as it is like this only. But the remaining two resistors can be drawn like this. Suppose if you take this as R1, this is R2, this is R3. This R2 and R3 are connected in parallel. R2 and R3 are connected in parallel because here there is a division and here also there is a division. So we consider R2 and R3 are in parallel, but this R1 is series with these two parallel. So you can redraw that figure as shown here, R1 plus R2 R3. So here first one 5 ohms as it is, but these two are in parallel. We have to find out what it is now. So it is going to be 1 by 5 plus 1 by the two are in series. One second. This not like this, it should be drawn like this. Second figure, these two R2 and R3 are in series. First one, so first one is 5 ohms as it is, but the next two R1 is 5 ohms as it is, but R2 plus R3 effective resistance is 10 ohms. Now, overall resistance will be, because they both are in parallel, 1 by 5 plus 1 by 10, then the result is going to be 2 plus 1 by 10, which is 3 by 10, and this is what 1 by R, and what is R? 10 by 3, which is 3.33 amperes approximately. You have to redraw that figure and then find out what it is. Let's see these questions again. This is case study question, first one. In the first case study question, they are asking to find the total resistance of the circuit is. It is given here an electric lamp of 20 ohms resistance, 20 ohms resistance R, and a conductor of resistance 4 ohms are connected to a 6 volts battery as shown in the circuit. So they both are connected in series. So R1 and R2 of 4 ohms, these two are connected in series. So they are asking to find total resistance, first one. So what is the total resistance here, first case? Total resistance is going to be 20 plus 4, 24 ohms, first case. And the second case, second question, total current I is equal to V by R. What is V? 6 volt by 24 ohms. 6 by 24. 6 by 24 is what? 1 by 4. 1 by 4 is 0.25 amperes. This is current answer. Total resistance. First answer is 24 ohms. Second answer is 0.25 amperes because it is 6 by 24. Second answer is B by R we have to take. Now third question answer what they are asking to find. We have to find out potential difference across the electric lamp. So what is V1? V1 is I into R1. I is 0.25 into R1 is 20 ohms. So what it is? 5 volts. V1. Potential difference across the bulb is 5 volts. In this one more what they are asking, conductor, potential difference across the lamp and conductor also. What is the potential difference across the conductor? V2 is equal to 0.25 into its resistance is how much? Its resistance is 4. So it is 1 volt. This is V2. V1 plus V2 is again 6 volts. Power of the lamp. Power of the lamp they are asking. Power is equal to V into I. Voltage is voltage across the lamp is 5 volt. So 5 into current across the lamp is 0.25. So it is going to be 1.25 watt. This is the power of the lamp because power is equal to voltage into current. Power is equal to voltage into current. Power is equal to voltage into current. So voltage is 5, current is 0.25. So power of the bulb is voltage into current. So that is the first case study question. Now let's see what is the second case study question in this. What is given here? Find out the following in the circuit given in the figure. First one, effective resistance of two 8 ohms resistors in the combination. Two 8 ohms resistors are connected in parallel. So how do we find effective resistance here? First question answer, because they are connected in parallel, 1 by R is equal to 1 by 8 plus 1 by 8, which is 2 by 8. 2 by 8 is 1 by 4. Therefore R is equal to 4. Effective resistance of 2 8 ohms is 4 ohms because they are connected in parallel. Second question, current flowing through 4 ohms resistance. We want current through 4 ohms resistance. Current is equal to I is equal to V by R. Now 8 volts will be divided across. You can redraw this figure as like this to understand better. The given figure can be drawn again like this. This is 4 ohms and the effective resistance of 8 ohms and 8 ohms is again 4 ohms only. So these two are 4 ohms, 4 ohms. They are connected in series. Now this is ammeter 1. Here one more ammeter is connected. Okay. Now we have drawn that 8 ohms and 8 ohms. So what happens here? Battery is given 8 volts. Potential difference is given 8 volts. Now this 8 volts will be divided across both first one and second one. They are asking to find potential difference across 4 volts. V is equal to overall current we have to find out first. How can we find overall current? Total resistance. Total resistance is equal to 4 ohms plus 4 ohms, 8 ohms. And total potential difference is 8 volts. Therefore, total current will be 8 by 8, 1 ampere. Means what? Here 1 ampere only it will travel. Here also 1 ampere current only it will travel. And when you want V1, V1 is equal to I into R1, which is 1 into R1 is 4. 1 into 4, it is 4 volts. Even V2 also I into R2, 1 into 4, that is also 4 volts. 4 volts and 4 volts. In both the cases, it is 4 volts only. In both the cases, it is going to be 4 volts. Second question. Power dissipated in 4 ohms resistance means first case. Here, what is the power dissipated? Here, what they are asking here, what is the power dissipated? Power is equal to what I said formula. Power is equal to V into I. We know V is 4. V is divided. V is 4 volts across 4 ohms resistance. And current is 1 ampere. So what is the power? 4 into 1, 4 watt. Power across 4 ohms resistance is 4 watt. Difference in ammeter readings, if any. See here, whatever ammeter, whatever current is here, here also current is same. What is that? 1 ampere. The voltage that ammeter is not connected anywhere through 8 ohms or 8 ohms. It is connected through both the cases. It is connected series only. For overall circuit only it is connected. In both the cases, there is no ammeter difference. That is, it shows the reading 1 ampere only. It shows the reading 1 ampere. Next question. Let's see this question number 3 case study. Here what it is given. Here in this case what it is given. 3 heaters are given. We have to listen carefully, observe carefully. 3 heaters. 3 heaters of 250 watt. 3 heaters of 250 watt it is given. And voltage is 100 volt. 3 heaters of 250 watt and 100 volt are connected in parallel to a 100 volt supply. The total current taken from the supply is, you have to find current. So to find out current, what we have to do, power is given, voltage is given, power is equal to V by I. So P is equal to V is 100. One case, 1 minute. Power is not V by I, power is equal to V into I. Power is equal to V into I, and I is equal to power by voltage. So what it is, I is equal to power is 250 watt and voltage is 100. So what it is going to be 2.5 amperes. What they are asking, the total current taken from the supply. Current across one heater is, it is 2.5, because they both, all the three are connected in parallel. I is equal to I1 plus I2 plus I3. So all the three are same. So 2.5 plus 2.5 plus 2.5. So total current is going to be 7.5 amperes. This is I. Total current is going to be 7.5 amperes. Next, in this only second question, that is first question, what is the total current? Total current, how we find? Current across one heater and take that 3 times. Then current across 3 heaters will be 2.5 plus 2.5 plus 2.5, 7.5. 3 heaters. Next question, the resistance of each heater. We want resistance. Now we know current and voltage. What is R? R is equal to V by I. Now V is 100 and I is 2.5. So what it will be? On 1000 by 25, if you multiply 10 in the numerator and denominator, it becomes 1000 by 25. 1000 by 25 is what? 25 ones are 25 fours are 0. So what it is? 40 ohms. This is the resistance of each heater. Resistance of each heater. When we want resistance, which formula we use? R is equal to V by I. We got already V, it is given 100, and we got I 2.5. We will take resistance current across one heater, because you want resistance of one heater. So current across one heater is 2.5 amperes. So R is equal to 100 by 2.5, which is 1000 by 25. We get 40 ohms. Now the next question, third question in this is, here we want the energy supplied in kilowatt hour to 3 heaters in 5 hours. So here 3 heaters are given. So 3 we have to multiply. 3 into, we will be having one formula, NPT, number of devices into power of the device into time. Energy is equal to, you remember this formula also, energy is equal to NPT. What is N? Number of devices, 3 heaters. What is P? Power of each device. Power of each device is what? It is given 250 watt power of each device. And how many hours it is working each device? 5 hours. So this is going to be total energy. So total energy is going to be what? 3 into 250, 750, 750 into 5. So we have to multiply this. 500, 5 5 is 25, 5 7 is 35, 35 to 37, 3750 joules. 3750 joules. We can also, or watt hours. We can write it as joules or watt hours. Now we have to convert this into kilowatt hours. When you want kilowatt hours, you have to divide this by 1000. Okay, watt hours we got. When you want to convert this into kilowatt hours, divide by 1000. It is 3.75 kilowatt hours. It is 3.75 kilowatt hours after we are dividing by 1000. 3750 joules we can say. No, not joules also. 3750 watt hours, watt hours only we can say. 3750 watt hours. But when you want kilowatt hours, 3.75 kilowatt hours. We are converting that into kilo. So it is going to be 3.75 kilowatt hours. Now what is this next question in this R question? What is commercial unit of energy and how it is related with joule? Commercial unit of energy is nothing but kilowatt hour only. Means what? How much power, how much energy is consumed in 1 hour time with a device rating kilowatt hours. So here rate of the device is kilowatt, and if how much energy it consumes in 1 hour will be called as 1 kilowatt hour. 1 kilowatt hour, that is what commercial unit of energy. And how it is related to joules? 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. 1 kilowatt hour will be equal to 3.6 into 10 to the power of 6 joules. You remember this point also. Okay, these are okay. The remaining few more questions are there. We will discuss in the next class or in the coming classes. Hope these sum of numerical problems will help you to solve your exams better, final exams better. You can leave and prepare for other subjects. Thank you.